top. These are just a little review. So it just says find the perimeter of the regular polygon. So before we get into that, I'm going to see if you guys remember. Does anybody know what it means to be a regular polygon? Because that's going to be a key to all the questions that we're going to do today. Do you guys remember what regular polygon means? Anything? Regular polygon. Okay. If I told you, like my picture here, this is a regular polygon down here. All right. This is actually one in the little picture here. Regular just means, I'm going to come over here. If you don't know this, I might jot this down. It just means all the sides are the same. So like if I had a triangle, and it would be an equilateral triangle. All the sides are the same. And this is not going to come into play so much today, but all the angles are also the same, so that all the sides are congruent, all the angles are congruent. So if we're going to find a perimeter of a certain shape, which we're going to do in like all the questions today, if it's regular, that means every single one of the sides would be the same. It would change how you would find the perimeter depending on what the shape actually was. So I'm going to see if you guys know how many sides these guys have. All right, so if I give you a hexagon, do you know how many sides a hexagon has? 6, right? Okay. So if I tell you, okay, we're going to find the perimeter of a hexagon. So we're going to add up all the sides. And I tell you the sides are 4 inches. How would you figure out your perimeter? 6 times 4. All right, so then my perimeter would just be 24, just plain inches. That's all you have to do. Do you guys remember how many sides an octagon has? 8. Okay. So then, now this one's a little weird because it's in radical form, but the perimeter would just be 8 times one of the sides. If I know one of the sides is 2 square roots of 3 or 2 radical 3, just multiply the numbers on the outside, and this would be 16 radical 3 for an exact answer there. And that's all you have to do. Just multiply the number of sides by what the side length is. That's all you got to do, and it would change depending on what shape you're looking at. So all these questions we're going to do today are going to be regular polygons, so all the sides will be the same length. Now, I have a little picture here, and I don't know if you guys got to this or not, but you can do this. A lot of the teachers didn't get to this, I feel like, because they ran out of time, but you can put a circle. It says you can circumscribe a circle is going to be what I'm going to put in this blank about any regular polygon. What it means to circumscribe is you draw a circle, and it would literally just go through each vertex of the shape. In this case, I've got a hexagon in my little example. So each vertex of the hexagon is going to be on that lovely circle, and there'd be basically like this little gap in between here where you don't have an area that's part of the actual circle. So the hexagon's inside there, but each vertex of that hexagon is on the circle. All right, now it says the blank of a regular polygon is the center of the circumscribed circle. So in this lovely picture here, the center of the polygon is the same as the center of that circle. So in this lovely diagram, right in the middle, that is the center of the circle. It's also the very center of that hexagon. And you could do this for any shape, but we just have a hexagon in the diagram there. All right, now I'm going to draw on almost every one of these little dotted lines except for one. So this says the blank is the distance from the center to a vertex. So the center of the circle, same as the center of the pentagon, or sorry, hexagon here. The polygon is what I meant to say. Each one of those little lines I'm going to draw on, not the one that has the right angle though. So that distance goes from the center to a vertex. Does anybody know, let me draw you a little tiny picture to the side here. So pretend the hexagon's not in there. If I draw from the center to a vertex of the hexagon, it's just a point on the circle. Does anybody know what that segment's called for the circle? It's called the radius. And so if you have a segment that goes from the center to a vertex, because the circle has to go through each one of those points, it's just a radius of that circle. It's also called a radius for that polygon. Just from the center to any vertex is a radius, because it's a radius of that circle. This last word I highly doubt you will have ever heard before, unless you've worked with this before. This one dotted line that I didn't color, it goes from the vertex just to one of the sides of the polygon. It doesn't go all the way down to the circle. It just goes from the vertex to the base of this at a 90-degree angle, and that is called the apothem. So just one of those drawn in there. That's called the apothem, and we're going to need that for finding the area of a regular polygon, so that's why I'm giving you these vocab terms at the top here. Is anybody having a question at the moment? Okay, let me scooch this up. Now, I did a hexagon for my picture here. You could do this for an octa, any shape, any regular polygon. I just put a little hexagon on here to help us kind of set up this formula. Okay, so I'm just going to kind of eyeball the center of this, and I'm going to draw a radius to just two of the vertices. If I drew that, how many little triangles would it make on the inside if I drew that to each vertex? Does anybody know? Like, I got one triangle there. If I connected each vertex to the center, how many little triangles would you have? 6. If you had a pentagon, you'd have 5. If you had an octagon, you'd have 8. So there would be, you don't have to draw all these in here, but there would be 6 little triangles in there. Okay, now I'm going to draw this to the side just to kind of work with you on it a little bit. The apothem that we just mentioned in the previous question goes from the center to the opposite side at a 90-degree angle. So let me just pretend this is any one of those triangles. They would all be congruent to each other. What would this little dotted line be just if I just gave you the triangle? What would that represent for the triangle? How would you find the area of a triangle? Do you remember? Yes. Okay. Area is 1/2 base times height, right? What would this little dotted line be for that triangle? The height. Okay. Now, this would be the base, right? Okay, here's where this formula comes from. Each one of these little triangles would be identical. So, each base of each triangle, every single one of those sides would be the base. All right, and each would have the exact same height. The height is the same thing as that apothem, which when I write this formula, we're going to use A. Here's how this works. If I would take each one of these triangles, right, and I did 1/2 base times height, what would you multiply that by to get the area of the whole figure? Times 6. Okay. Now, instead of doing this, this is what they did. They developed a formula. See if you guys think this makes sense. What would, if I called each piece around the outside there a base, what would my perimeter be? No, pretend we don't know. We don't know the length of the segment, but how would you find, like, each one of these is B? What would the perimeter be? B times 6. Okay, here's the deal. Instead of doing 6 different triangles, they set up this formula, and it goes like this. It's 1/2. The apothem is the same thing as the height of each one of those triangles, and instead of doing the base of each of the triangles, they do the perimeter of the whole thing, and that formula will give you the area of all those little triangles, but just doing it in one step. So instead of using the base of the triangle, they use the perimeter to get the base of all the triangles. And the A is just the height of each of the triangles, and the 1/2 is part of your triangle area formula. That's literally all it is. By changing this out to be the perimeter, you do all the triangles in one step. And I don't have to worry about, like, if I had a hexagon here, we would do a 6. If we had a pentagon, we'd do a 5. If we had an octagon, we'd do an 8. But by doing the perimeter, you take care of that without having to think about it. So there's 2 things you need to find the area of a regular polygon, and that's the height of one of those little bitty triangles, which we call the apothem, and then the perimeter, which all the sides should be the same. So we're going to work on this formula just a little bit. It's not hard. And I set up to the side just so you guys would have all the information you need to find the area. So A is for the apothem, P is for the perimeter. Okay, so this says find the area of a regular pentagon. How many sides does a pentagon have? 5. Perfect. Okay, with sides 11.6 and an 8 centimeter apothem. So right away I know the apothem, they just tell that to me. I don't specifically have the perimeter given to me, but I think we have enough information to figure it out. So if I know this is a pentagon, how would you find the perimeter? 5 times what? The 11.6. They tell you that one of the sides is 11.6. If it's regular, then all 5 of the sides are exactly the same. So we're just going to do 5 times 11.6. And I got a nice number. I got 58. Now, whenever you do perimeter, you're not doing it in 2 dimensions. It would just be around the outside edge. I know I don't have a picture here, but I would just have 5 times whatever the side length is. Now, to do your area, you would literally just do 1/2. Your apothem would be 8, and your perimeter is the 58. And you would just type that in your calculator. That's going to give you your area, and you're done with the question. You just might have to do a little bit of work to find the perimeter. So I'm doing 1/2 times 8 times 58. This would be 232. Now, this would be centimeters squared because we'd be talking about an area. But that's literally all it is. Does anybody have a question? Okay, if you look at this diagram on the very bottom here, can you tell me, looking at the picture, like what the apothem would be? The 12.3. On the back, it's a little bit harder because it's not going to give you the stuff up front. All right, now this is a decagon. Does anybody know, without counting that picture sides, how many sides a decagon has? 10. If you want to go through and count, you can see there's 10 here. So basically, if I drew like a radius from the center to a vertex, if we did that all the way around, we'd have 10 of these little triangles. But instead of having to find the area of each one, if I get the perimeter, I get all the bases of the triangles in one step, and I already have the height. So if I've got a side is 8, how would you find your perimeter? 10 times 8, which equals 80. This one would be in inches, and then we're golden. We just need to do our area formula. So it's 1/2, and feel free to type 0.5 because I feel like that's less buttons, times 12.3 times your perimeter, which is 80. That's the one key thing. You got to find the perimeter. If they just give you the side length, then we might have to multiply it by something to figure it out, and then you got your area. So I got 492, and this area, the label would be in inches squared because we're talking about how many squares would be able to fit into that lovely decagon. Some of these numbers are huge when you do them, and some of them have decimals, so don't think you're doing anything wrong if you get like a huge answer. Is anybody having a question at the moment? Okay, the ones on the back are just a teeny tiny bit harder because they're not going to come out and tell you, maybe they don't come out and tell you the perimeter, or they don't come out and tell you the apothem, so we might have to figure it out. So that's what's going to go on the back page here. All right, so I have in the directions, find the area of the regular polygon. Now this is going to be a little weird in a couple of these questions. We don't want to round multiple times as we're doing the problem because that makes our area not as accurate. So it says find the exact perimeter and the exact apothem. I'm going to explain what I mean by that as we start to do the questions here. So they do give me the side length, right? They tell me the side is 7.2. And how would I find I can find my perimeter here real quick. How many sides do we have in the shape? What shape do I have here? Pentagon, right? All right, so all I'm going to do is 5 times the 7.2. Right, there's 5 sides, each one of them is 7.2. So 5 times 7.2 is some number 36. There's my perimeter. All right, now, the thing I don't know is the apothem here. So that's what we have to figure out. So let me go ahead. They give us a radius. So a radius just connects the center to a vertex. So I'm just going to draw a little triangle here. This would also be 6.1. So would this side. And what I need is the lovely apothem, which is the height of that little triangle. And I could draw this anywhere on the figure in terms of like I could rotate the triangle around or whatever, but I'm just going to put it on this bottom triangle. But if you wanted to draw these in, any one of these triangles would have the same, the sides are the same, they're each 6.1. The apothem is the height of that triangle. All right. If the entire side is 7.2, what would this much of it be, or how could I figure it out? Divided by 2. If you, each one of these just little isosceles triangle, because if this is 6.1 and this is 6.1, that's the height going right down the middle. It's going to split the base into 2 equal pieces. So I'm just taking 7.2 and I'm going to cut that in half. All right, so on either side of this, 3.6. My goal is to find this apothem, so I'm just trying to get you there. All right, so I got a little bitty baby right triangle right here. And let me just come draw it to the side so I can have a little bit more space. This is 3.6, this is 6.1. This is the apothem, and I need the apothem to find the area of this pentagon. How could I use the fact that that's a right triangle to help me find that apothem? Pythagorean theorem. That's literally it. Now, these are kind of working with some nasty decimals when you do this, but here's the right angle. So the 6.1, that's the hypotenuse when you set up your Pythagorean theorem. So the apothem is one of the legs. So it would be a squared plus 3.6 squared equals 6.1 squared. Okay, now this is where I'm going to get into talking about how to do the exact answer. So I'm going to subtract 3.6 squared from both sides to get the a squared. So I'm just doing 6.1 squared minus 3.6 squared. And this does not give me a nice number, but that's okay. 24.25. Now, if you take the square root, this is, I'm going to show you this on my calculator just so you can see. If you take the square root of a number that's not a perfect square, you're going to get a garbage decimal. So I have this decimal, this long decimal, and we don't want to round multiple times as we go through the process of solving this problem. So when it says leave up here at the top, exact answer, what I'm going to do, instead of typing that into my calculator at the moment, I'm going to write that the exact apothem would be the square root of 24.25. That way, when we actually do the area, we're going to round to the nearest tenth, but I don't want to round multiple times as I'm doing the problem because that will make my answer really not as accurate as it could be. When I actually go ahead and do the formula, then I'll type it in there, but this is what I mean by the exact apothem. It's the square root of that number. It's just this weird decimal. Okay, you got those two pieces, so you're good. Take 1/2. Your apothem is that square root 24.25. And then just, if you're typing this in the calculator, make sure you close the parenthesis if yours pops it up and put the 36 for the perimeter on the outside of the square root. Otherwise, you're good. So we're doing 0.5 times that square root 24.25. And then just make sure it close the parenthesis, or if you're using a graphing calculator, just use the arrow key so you're not underneath the square root anymore. And the 36 on the outside. So that's 1/2. Apothem is the height of one of those triangles. 36 is the base of all 5 triangles in one step. And then this is going to ask you up here for all these questions, the nearest tenth at the end of the problem. So this is 88.6. It's not bad to do, just sometimes some of the questions are going to work with some icky kind of decimals. Is anybody having a question? Okay, so that one I had to find the apothem. This one's going to give you the apothem, but it's not going to give you the perimeter. So I can write this right now. Apothem, I can see in that lovely problem. And forgive, I should have had a right angle mark on that. I should have done that. I didn't notice it till just a second. So this should have a right angle. Okay, so I don't have the perimeter here. This one is a little bit trickier. So this guy is an octagon. Got 8 sides. So when I do my perimeter, it's going to be 8 times whatever I figure out the side length to be. So if I draw another radius in here, that would be like one big triangle. There would be 8 of those if I went all the way around. The radius here would be 17. The apothem, that 15.7, would be the little dotted line. Okay, now here's what I'm going to do. I'm just going to, I know if I draw that little dotted line, it should split that side of the figure into 2 equal pieces. So you can use whatever variable you want. I'm just going to use x. So if I draw this to the side here, let me just kind of color what I'm doing. I'm going to use this to help me find the side length for each of the sides in this octagon. So if I come over here, right, the radius is going to be the hypotenuse of that triangle. The apothem is going to be the height of that triangle. And then x, if I can figure that out, I can figure out the perimeter here. This is just going to be Pythagorean theorem again. So the 17 is going to be your hypotenuse. So I'd have the x squared and the 15.7 squared. Those are going to be my legs. So what I'm going to do on my calculator, and this is not going to be a nice number, is I'm going to take 17 squared minus 15.7 squared. Alright, and as you guys can see, we have 42.51, and again, this is kind of similar to the last question. I'm going to have to take a square root of that, but I don't want to round this multiple times. So, just x would be the square root of 42.51. What would the whole side be? Like if I looked at this triangle, because I'm trying to find the perimeter, what would that whole side be? You would multiply it by 2. Does that make sense to everybody? Okay, so like this would be 42, root 42.51. This would be root 42.51. So together there's 2 of them. This would just be one side. Alright, I'm going to try to find my perimeter here. How many sides does an octagon have? 8. Okay, so your perimeter would be 8 times that 2 root 42.51. Just trying to keep an exact answer so we don't round multiple times here. All you got to do there, 8 times 2 is 16. Radical 42.51. That would be the perimeter. So the base of all, if we drew them all in there, there'd be 8 triangles. That would be the base of all of them. So this would be 16, and I know this is a lot because it's got that radical, but we just don't want to round multiple times as we do the problem. So that's why I'm going to give an exact answer there, and we can round at the very end. Then our area will be much more accurate. Okay, so my area, it's a 1/2 or 0.5. Your apothem there is that 15.7, and then your perimeter is 16 times the square root of 42.51. We're literally just typing this into the calculator. It's not terrible to do. So I'm going to do 0.5 times 15.7 times 16 times square root 42.51. And again, a lot of these are garbage decimals, so don't think you're doing anything wrong when you're doing these problems. So this area would be 818.9. This was in meters if I look back at the problem. That one's the trickiest, I think, of what we're going to work on today, because like I said, when we did this, you get half of the side, so you have to multiply it by 2, and then you have to multiply it by how many sides there are to get the whole perimeter. Is anybody having a question?